Hello, and welcome to a Minitab 18 episode of Fun Times and Statistics. We're going to be looking at the loan application data today and working on doing correlation and linear regression, specifically simple linear regression. So I've downloaded our loan application data. If you read through the description, basically this is just, a bank's data from a bunch of people's loan applications. And there's only 30 people in this data set. So it's, relatively okay in size, but maybe not big enough if we've got some non-normality happening. All right, let's start out by creating a scatter plot. So our whole goal of this little video is going to be to try to predict savings. So as you look at some of these variables in their description, you're like, okay, I could see where that would have an impact on people's savings. So for instance, if you've been employed somewhere longer, you have a more steady job, you've been able to save more because of that. Maybe your age, you're older, you've paid off your debts, so you're able to save more. You have more education, so maybe you got a better job or a higher paying job, so you're able to, save more. Or you have a higher income, which, might make you save more. Now, notice like debt and credit cards, usually those are pretty similar, so we're expecting those to probably, have a negative effect possibly on our ability to save. And then we have the variable we're looking to predict, which is savings. So keep that in mind as we go through and do these. So first up, we're going to create a scatter plot for income versus savings, and we're going to use income as our explanatory variable, also known as your predictor variable. You may think of this as your x, and then savings as our response, because that's the thing I'm trying to make predictions about. I want to predict savings. And we're going to describe the association we see. So we're going to go to graph, scatter plot. We're going to select simple. We're never going to use any of the rest of these, so that's all good. All right, and now for my y variable, I'm going to put in savings. You can just double click to put it in there. And for my x variable, I'm going to put in income. Now, as you look through this, you'll notice that I have lots of other boxes. So if I wanted to do multiple scatter plots at once, I can. So maybe I want to do like, I want to see if age does a good job of describing savings. I can do that as well. Now, you don't need this to do number one. I'm including that as well just for fun. So you can see that it'll produce two of them. And you think you can do up to 20 if I remember. Yeah, up to 20. We don't need any of the rest of these settings to set this up. We just need to hit OK. Boom, boom. So there's our two scatter plots. Fun times. I really only needed the one for income. I did the age one just so you could see I could do two at once. Just as a reminder to copy a graph over, hover your mouse in the gray space, then right click to go to copy graph, and then paste it into your document. So what we're going to do now is we're going to describe the four parts to association. So form, outliers, direction, and strength. And I'm going to make my scatter plot just a little bit smaller so that I can fit my description here, and I'll make it bigger on the left-hand side on Minitab so we can look at it. So it does look pretty straight to me. It doesn't look like it has a big curvature to it. So I'm going to go ahead and call it linear. Oops, I usually do this in a different color. What do I feel like today? I usually do red. Let's do green for fun and difference. Christmas times. Anyway, looks pretty linear. There is quite a bit of scatter, but it was easy for me to see the relatively straight shape. So I'm going to go ahead and call this strong to possibly moderate. If you want to get real inventive, you can call this moderately strong. Now, I know what you're thinking. You might be thinking, oh, well, look, it's very sparse up here. Are you sure it's strong? Well, what you might notice is I have more people in the smaller, like below 50,000 incomes, and that is one of the reasons why, like, it looks like there's less of a pattern going on up here. You just happen to have less points up there, so less people with those levels of income, which makes sense. I really want to know what's happening with, like, this person who's, like, got so much savings, but yet kind of median kind of income, close to, like, the center. I don't know. We'll see what's going on. Anyway, strong, moderate, I don't know. It doesn't look like it has any outliers. This one's on pattern, so it's not questionable. It's along that straight pattern. These two are kind of off by themselves, but they're close to each other, so I think that's fine. I'm going to say it has no outliers, and it looks pretty positive. Just as a reminder to tell positive, if you start at the one end of the data, like around about here-ish, and you move in the positive x direction, which would be to your right, in order to return to the data, if I have to move upwards, that's also the positive direction in the vertical axis. So positive, positive, it's behaving the same way. If I had to have moved downwards to obtain reaching the data again, that would mean that I had a negative relationship. So, because they would be moving opposite each other. Cool. So it looks like, I mean, I fit the requirements to be able to do correlation. It looks linear, it's pretty strong. There's no outliers, and positive actually doesn't matter. We need to check if it's linear to be able to do correlation. So to do correlation in Minitab, it's actually pretty simple. We're going to go to Stat, Basic Statistics, and then roundabout towards the end quarter is correlation. So again, Stat, Basic Statistics, correlation. All right. And then I'm just going to throw in income and savings. Now, one of the things I talked about in the video is how it doesn't matter what order you're putting it in here. I talked about how they were symmetric. This is because like correlation is trying to measure the relationship, so it doesn't care who's X and who's Y. So there's that. You'll notice I unclicked the display p-values box because we don't need it to do this, and we are doing what's called the Pearson correlation. Let's go ahead and hit OK. All right, so there's my correlation value. I'm just going to copy it and paste it into my document. Oh, and it went in green. So one thing that's nice to notice about this is, yes, it is pretty strong like we saw up here, and it's positive like we saw up here. Remember, when we talk about correlation, its relationship to association is it describes strength and direction. It doesn't really tell you about outliers or linearity. It assumes linearity, so you really shouldn't try it on things that don't look linear. Speaking of things you shouldn't try, let's do something a little bit wonkier. So you might think to yourself, you know, some of these other variables available in our data set might be more better. That just is not good English. Might be better at predicting savings. Let's investigate. So what we're going to do is we're going to do the correlation for a bunch of these guys together and see if we can see if one of these variables is better at predicting savings, or might be better at predicting savings than income is. So we're going to do what's called a correlation table, where it just does a bunch of correlations at once. So we're going to go back to Stat, Basic Statistics, down to correlation. And you'll notice I already have income and savings in there, so I want to throw in age, debt, and credit cards. You actually can put any number of variables in here. Oops, did I accidentally get rid of savings? I think I did. Oops. So I got age, debt, savings. Is there anything else I want in there? Income. Oh, it's because I highlighted it. Good job, teacher. Anyway, you can put any number of variables in here at once, and it'll give you the correlations between the respective variables. Let's hit OK. All right, I've got my table, and I'm going to copy it and paste it over here. And I hate it when it wants to automatically number everything. Let me make this a little bit bigger so it's a little easier to see. No, oh my. When I talk about it, that was a little too much. Okay, so let's take a look at this. In looking at correlations, how you would read this is the value represents the correlation for the two variables in both the row and column. So this right here, the correlation of 0.14, it goes with age and debt. Okay. So you'll notice that I only get like a lower half of this. There's some reasons behind that. So there's no entry here in this cell, because debt to debt would be, well, it's comparing it to itself. It would be a perfect relationship. So Minitab knows that you wouldn't bother trying to use something to represent itself or predict itself, because that's never going to give you anything other than, oh, it's perfect at predicting itself, and doesn't help you at all. So you notice there's no entry for credit card with credit card or savings with savings. But you might ask yourself, well, what the heck? Why isn't it doing debt with credit cards? Why isn't there an entry right here? Yeah? Well, it's because it already has debt with credit cards. It's right here. See, debt, credit cards, debt. It's kind of interesting. Anyway, so you'll notice to predict savings, I got to look down this row. Oops. And this column, because it appears in two places. Occasionally this will happen. So you look at these values I've highlighted in yellow, because these are all correlations that are associated with savings. In particular, let's see, 0.874, 0.143, 0.353, 0.581. Okay, so ask yourself, which one of these is the strongest correlation? It's the one with income. This is the strongest because it is the closest to 1 or -1 and farthest from 0. Now, which of them is the weakest? That would be debt. Not because it's negative, but because it's the closest to 0. So looking at all the correlations in here, which is the weakest one? that would be the 0.140 because it is the closest to 0. Again, sign doesn't matter so much when it comes to describing strength. The sign, as in negative or positive, tells you about direction. So be careful with this. One of the number one mistakes I'll see people make is when they see a negative, they think that means worse. It absolutely does not. That just means direction. Closer to 0 means worse, regardless of sign. So as we look at this, we might notice that, hey, it appears that savings and income, oh no, it looks like I fooled you, like that was the best one all along. So clearly that's going to be my best predictor for savings because it has the strongest correlation and it looked linear. It's very important it looked linear. But then just to mess with you, I asked you a different question in 4 because life, I don't know. Anyway, so how much the variation in savings can be explained using credit cards? This is asking you about the R squared between savings and credit cards. So this is R squared. To do R squared, you just need to square R. So I need the R value between savings and credit cards. Where's credit cards and savings? There it is. So negative 0.413. Is that right? Yep. For some reason I want to put the 0 in there. That's a little hard to read. When you square that, you will get a number. Let's calculate it. 0.413, make it negative, square it. Ooh, that's small. 0.01706. I'll round it to there. So when you look at this, remember when we interpret R squared, we do it as a percentage. So this is going to be 17.06%. Yikes. So if I would have used credit cards to predict savings, it would have done a terrible job. It would only have accounted for about 17% of how much change or differences we might see in savings, which is very much an indicator that it would not be a good choice. Okay, let's move on to creating a line of best fit, also known as a least squared regression line, or what's another name for it? Linear model. There's so many names of this, it's dumb. Anyway, so we're going to find the equational line between income and savings using Minitab. So I'm going to let Minitab do this for me. There are a couple ways you could do this. What you could do is you could go to stat, basic statistics, display descriptive statistics, throw in income and savings, then tell it, hey, I just need the means and standard deviations for these two. And then use their correlation, which we found right here, along with these 4 pieces of statistics. And then, why am I at a loss for words all of a sudden? And then the formulas that we had in the notes to do this. So that's one way to get around it if you want to do it the hard way. I'm lazy. Let's do it the easy way. So we're going to go to stats. Actually, I'm trying not to say the I'm lazy bit because they're like, people are like, there's negative, blah, blah, blah. Yeah. Now I'm just complaining. So we're going to go to stat regression fitted line plot. If you're somebody who uses lots of different sources for our course, like if you use YouTube or Chegg or StudyBlue or any of the 8 million other study.com and all those people, they might choose a different route to do regression because there are a lot of options in this menu. You might notice, like, oh, look at all these. And there's even this one that's got some stuff too that you can use. There's lots of ways to use and make regression on Minitab. We're going to use fitted line plot because in my opinion it is the easiest one to do. So there we go. So response, that's the thing I'm trying to predict, which is savings. My predictor I'm going to use to do that is income because income was linear and fairly strong. For now, that's all I'm going to do for my setup for this. So just a reminder, this was found under stat, regression fitted line plot, and we're just putting in the X and Y for now. There are some later questions in this that I will need to use different options on this to do, like 8 and 9 in particular. I'm going to have to do some extra graphs so you can anticipate that, and I'm going to store some extra stuff, so I'm going to use storage to do that. But for now, let's just create the line. Bloop. All right. So the first thing it gives you is this lovely graph of a fitted line plot. So it just gives you an idea of what it looks like. Looks pretty much like what you might have expected it to look like. You notice these two seem to be far away or farther than what you might expect. Right here is the equation, the thing I actually need to answer the question, which is actually kind of hard to get off the graph, so I'm going to get it from somewhere else, as you'll see in a minute. And then it also gives you the R squared adjusted value, which is, R squared value of 76.4, so I wouldn't have to go and calculate it like I did in number 4. So I'm going to minimize this and show you the session window of what it looks like as well. So here we go. This is what I actually needed, the regression equation. So I'm going to copy it and paste it into number 5. You'll notice, why Why does it always want to number everything? You'll notice that right below it is the model summary, which gives you the R squared value as well, in case you were looking for that. Good times. Alrighty, so let me just make this a little more noticeable. So we're going to use that equation to predict what somebody will save if they make 72,000. I'm just going to steal this. There we go. And then since the income is 72,000, I'm going to multiply by 72,000. Ta-da! Let's pull up my calcumajig. Clear, clear, clear. Let's see, 72,000 times the slope, 0.2757 equals plus 7828. The weird thing about the Microsoft calculator is this is where I would make it negative, using that little button and then hitting equals. So I could have actually just did subtraction, which would have been fine. Anyway, so the result is that person, if they follow the linear regression model, should shave, wow, just over $12,000. Since this is money, I'm going to put 2 decimal places, which I probably should have watched my rounding with this anyway. Just as a reminder, if you want, you can make Minitab show you more decimal places than this. I guess you can't for linear regression. That's kind of stinky. Okay, so using my results for number 6, calculate the residual. So I've got the prediction, so I need the actual value to do the residual. So just a reminder, residual is always actual. I always spell actual with too many C's. Minus predicted. So our predicted Y is the one we know, and that's the $12,022.40. And then I need the amount they actually saved. So you go over to your data and you find the row where the person makes 72,000. There's their income. Their savings during that was actually 12,000. So my model wasn't too far off with that. So I'll do my subtraction. This one I can do in my head. Negative $22.40. Woohoo. Let me make a space here so it's a little easier to read. So my model actually over-predicted this by about $22, which isn't too bad considering most of these are in the thousands. Now, looking at one value is never going to be enough for you to tell how far off your model is. And that's why we need to do some residual graphs and to do some residual storage. So we're going to redo this again and move on to 8 and 9, where we're going to evaluate, did my model be as accurate as I think it be? Here we go. So find the line of best fit for income to predict savings, store the residuals, and fits. So I'm going to do the same setup I did before. So I'm going to go to stat basic statistics, stat regression fitted line plot. Oops. And then I'm going to make it store some stuff. So I want the residuals and fits. So fits is what Minitab calls the prediction. So I'm asking it to give me all my y-hats and my residuals. So looking back, I'm asking it to do 6 and 7 for all the income values and all the savings values. Get the idea? I'm going to hit OK. OK again, and here they all are. I don't need the graph. So for instance, my residual for 72,000, oh, it's a little bit more accurate here because it's not rounding as much. And there's the fit value, a little more accurately because it's not rounding. Interesting, right? Okay. Yep. And so that's it. What's interesting is if you look at these residuals, some of them are huge. like this one, there's almost like, it's almost $4,000 you're off by. Oh, that one's even bigger. Oh my, look at that one. There's some places where this is bad. Like look, $7,000 off. Oh, yeah, that's not good. So a reminder, so the fit values are the predicted values. So there's one, and the residuals are the error values. So what we're going to do next is we're going to ask Minitab to graph them for this so we can evaluate whether or not the model was successful. So remember, there are 2 things we're looking for in residual plot is does it look nearly normal and does it look like it has equal spread? So we're going to go back to the same place we just were at, stat regression fitted line plot. I'm going to hit the graphs option this time. And I'm going to want a histogram of the residuals and the residual versus fits. and the normal probability plot for the residuals. Now, if you want, you can do 4 and 1. I'd never include the residual versus order unless I'm doing something where order matters here. And since order doesn't really have meaning here, I'm not going to include it. So let's go ahead and hit OK. I'm going to hit the storage button and turn these off because I don't need it to do them again. And hit OK. And there we go. So remember, we're with the histogram and the normal probability plot. We're looking to see, does it look fairly normal? And to be nearly normal, it just has to have some of the characteristics of the normal distribution. So for instance, this one looks pretty unimodal. So for that alone, that tells me that this is probably good enough. The other thing we're looking for is when we look at the normal probability plot, we want these points close to the line. They are, except for 2 of them. So most of them look normal. So that's enough for me to be considering them nearly normal. Let's copy this graph over. Woohoo! And copy the histogram over. So these graphs both tell me the same thing. It looks nearly normal. Let's write this big enough to where you guys can see it easily. Looks nearly normal since a majority of the points in the normal probability plot are close to the line, and the histogram, I shouldn't say and, it's or. You really only have to look at one of them. Or the histogram of residuals is unimodal, which is a characteristic of the normal distribution. Just as a reminder, the characteristics of the normal distribution are it needs to be symmetric, bell-shaped, and unimodal. We just need 1 or 2 of those to consider it nearly normal. This one has 1, good enough. And like looking at the normal probability plot, almost all these are really close to the line, so I'm good with that. These 2, 2 of them. 2 out of 30 I can live with. Let's take a look at the versus fit graph. So for the versus fit graph, we're looking for something totally different. We're looking for a balance of the residuals. This is also known as homeostaticity, which is a hard word to say and why we don't teach it to you, because honestly, you're probably not going to remember it, but it's okay. Anyway, so what I'm looking for is, do I look like I have about an equal number of points above 0 as I do below 0 and no pattern whatsoever? So as you look at this, this one's actually kind of bad because although I do look like I have an equal number of points above and below, it does have a sort of conical pattern to it. So it starts out really small in error, or all my errors are fairly similar, and then it gets bigger over time. So I get more error as I increase in my fitted value, or as it might say, in my Y, my response. So the bigger the response, the worse this does at predicting it. So that's not a good thing, unless you're only looking to predict small values. So if you're only looking to predict people that had less than $5,000 as their savings, you know, this would do fine. But once you get bigger than 5,000, it's kind of all over the place. All right, so looks, equally spread since the number of points above 0. So we're looking at number as in counting them. You never actually have to count them, you just got to ask yourself, does it look like it's about the same number? Above 0, remember the 0 is the line in the middle, is the same as the number of points below 0. Yay! However, there is a cone pattern in the data. So we should be cautious about using these results. Because, there is a pattern in the data we systematically missed one. So when you see a pattern, there's something that you've missed. And it's in a systematic way because it has a pattern. If it has no visible pattern, then it's not systematic, it's random. Random you can't do anything about. So as you look at this, this means that I probably should be using a second variable in here. My guess is probably if you add in debt along with income, this will probably take care of it. But we don't do multiple linear regression in Stat 1. If you'd like to see how to do that, take Stats 2. P.S. It's totally, definitely including debt. So if you want to see how to do multiple linear regression, that's where it shows up. And I just shrinked the thing I needed. That's my life, man. Okay, so last but not leastly, let's talk about the value of r squared, and we're going to provide an interpretation or explanation of what this looks like in context. Remember, in context means that you can't just say, it's this, for this variable and that variable. You know, like if you use the word this, that, it, or theirs, like you probably are doing this wrong. If you can't be specific, you don't know what you're talking about. Or as John von Neumann said, fairly famous mathematician, it's hard to be precise when you don't know what you're talking about. So if you're not precise, I know you don't know what you're doing. So there's a couple places to find r squared. First of all, you can find it in the model summary on the session window after you do linear regression. You can also find it, let me grab the graph, in the fitted line plot right here. So clearly ours, it's a little more accurate using the model summary, so that's the one I'm going to use. So our r squared value, which I'll abbreviate it like this because that's what Minitab is doing, is 76.44%. And then I'm going to write an interpretation of it. So remember, this measures how much of the changes or variabilities or variability that I see in my response that I'm able to predict using its linear relationship with my predictor or explanatory variable. So about 76.44% of the variability. So remember, all things vary. This says that when it changes and does different things, or if I increase or change my savings, I can explain it using the other variable. Variability. All about that change, yo. Can I predict things that change? Because then I can use this to do stuff. In savings. So I'm capitalizing these so you can recognize when the variables come in. Can be explained by its, ooh, I don't like its. There's only one subject here, so I'm good. It's savings. Linear relationship with income. Oops. So another way you could say this is, yeah, I don't like its either. That's the wrong one. No, it's not is, it's a possessive one. Right, it's linear relationship with income. So if I were to use something else, like something non-linear, that's clear. And I'm able to explain changes in savings using changes in income. So r squared is really telling you how much you were able to account for in your model by using just this one predictor. And 76% ain't bad. It ain't great, but it's definitely enough to get you a pretty good prediction. And again, we did notice that this seems to be worse for larger incomes, especially when we looked at the residuals. So in particular, this model would be probably more accurate actually if you broke it into two pieces and did the stuff below 50,000 and the stuff above 50,000 separately, because I betcha the people making above 50,000 has a lot more variability in it than the stuff below 50,000, because that stuff was pretty tight when we looked at the scatter plot. So there's some things for you to think about. If you, yeah, that's all I have. Wow, that went kind of fast. Wish I'd use some other variables for this. In your mini tab for this week, you will be asked to consider variables and make a decision. So I'm going to scroll back for a second and go over one last thing. So I do believe I have you using the best predictor and the worst predictor, so you can see just how bad it is if you use a bad one. So keep that in mind. You're going to be doing more than one model, not just one like I did here today. So you're going to go through these steps a second time with the worst predictor. Worst predictor, not protector. Yeah. Okay, peace out.